Bismillah ar-Rahman ar-Rahim. Let's look at this exam problem. The two-bond system is fed by a stream with flow rate of 1 million gallon per day. Okay, and a BOD non-conservative pollutant. Okay, remember we mentioned in class if it's a conservative, K is 0, but BOD, of course, BOD is non-conservative, and that's why it will be biologically degraded. So that's why we call it non-conservative. Concentration of 20 milligram per liter. The rate of decay of BOD is 0.3 per day. The volume of the first bond is 5 million gallons, and the second is 3 million gallons. Of course, the gallons should be here. 3 million gallons. Okay, assuming complete mixing within each bond, find the BOD concentration leaving each bond. Okay, what is a bond? A bond is like a hole in land where they put the pollutant inside, and then it mimic CMFR. It's completely mimicking CMFR approach. So this is bond 1. And there is bond 2. Okay, so the flow rate entering the bond number 1 is 5. The bond number 1 is 1 million gallon per day. And BOD non-conservative pollutant concentration of 20 milligram per liter. So 20 milligram per liter is here. This is CN entering the first bond. The rate of decay of BOD is 0.3. So K, it's 0.3 per day. The volume of the first bond, here the volume, of course this is filled with polluted water. It's 5 million gallon, and the second one is 3 million gallon. Once the treatment finished from this one, the effluent leaving the first one will go to the second bond, will be also reacted in the second bond, and then will leave the second bond to the outside. So these two bonds are in series. Okay. Now, complete mixing within each bond. He need to find out BOD concentration leaving each bond. So he need to find out, let's see, C1 and C2. Let's look at the equation for the CMFR. You know, this is completely mixed. Flow rate in, flow rate out is the same, and there is, of course, completely mixing within. So this is this mean CMFR design calculation. So let's look for the equation for the CMFR. VdC over dt is equal QCI minus QC out minus volume KC out. And in most of the design, we always design for steady state, so this is going to be 0. And this would give you, of course, he needs C out, so he needs C1 first, and then you will find C2 later. So you will do Q C naught plus volume K C naught equal QCI. So C naught is as a common factor is equal QCI over Q plus volume K. Well, if you want to continue over this, you could just rearrange it like that. If you divide by Q, at the top it's CI, down it's Q over Q is 1, and volume over Q, you leave it, times K. Okay, so what is CI? CI is 20 milligram per liter, and it was given here, 20 milligram per liter, and this is the inlet food to the system. So CI is 20 milligram per liter. 1 plus. What is the volume of the first tank? It's 5. I'm gonna leave 5 million gallon because I'm gonna cancel it out with million gallon per day. So this is divided by Q, entering 1 million gallon per day. So million gallon will cancel with million gallon. You will end up with day at the top. And what was K? K is per day, which is good. So we have to make sure that the units are consistent here. 0.3 per day. Remember, 5 million gallon over 1 million gallon per day. Million gallon will cancel with million gallon. You will end up with a day at the top. And you can see that K is also per day. So we are fine with units here. And this would give you, if you do the multiplication, it will give you 8 milligram per liter, and that is C1. Now, we're going to use C1 as an influent for the second bond. Okay, so we'll do the same thing. This is, we had to put it for the first bond. Let's look at the second bond. Okay, so C naught is equal. Now we're going to use the C1 that is going to be entering the second bond. This is 8. Milligram per liter divided by 1 plus 5 million gallon. Oh, no. The second bond, remember, it's 3 million gallon. So 3 million gallon over the flow rate is 1 million gallon per day. This will not change. Flow rate throughout the system times K. So 3 times 0.3 is 0.9. So you could cancel out everything, and you will end up with 4.2 milligram per liter, and that is C2. So now we found out the concentration of BOD leaving bond number 1, 8 milligram per liter, and leaving bond number 2, 4.2 milligram per liter.